Okay, today we will start Snowflake System Tables, one of the very important topic. Okay, so system tables. Any database, okay, it may be database or data warehouse, it may be on-premise or cloud, it will have some system tables. Or what is the system tables? Till now we have heard, one term like metadata, right? Metadata. Metadata means the definition of metadata is it's data about data. So in every database, what are the different objects, tables, views, databases, stored procedures, like everything, schemas. These are all, database objects we call tables, views, cursors, functions, procedures, stored procedures, users, schemas, databases. So these are all database objects we call. So this information will be maintained in the data dictionary, which is called metadata. Metadata means data about data, means it holds the data about what are all the users, what are all the tables, what are all the views, what are all the functions, what are all the procedures created in the Snowflake system. Okay, when it's created by whom, or when it's lost accessed. All this information will be stored within the Snowflake system. Okay, that means there are some tables which hold all this information when this table is created, who has created. Okay, so when it's lost, altered, or lost accessed, all this information is created, is maintained within the Snowflake tables. Okay, so that is called Snowflake, metadata, because metadata means it's data about data, or we call it as data dictionary, means it will have everything about Snowflake objects. For example, a table is there when it's created, who created, okay, when it's accessed. Similarly, a view is there, who created, when it was accessed. All this information is maintained within the Snowflake system. Okay, so so those tables are called system tables. Okay, so if you come here, as soon as we log in, okay, so for example, go to, okay, so data, then you will have all the databases. Within that, you will see by default this public and information schema, right? So this information schema holds all this metadata, or the information about all the our Snowflake objects. This information schema, okay, this information schema holds information about all the system tables. Okay, so if we have tables, it will have all the tables information. If you have views, it will have all the views, whatever it may be. Okay, it will have all the information that is there within the Snowflake. Okay, so although we are seeing here 34 views, means it will have views, okay, which will hold all this information. Okay, so means Snowflake people will create views, okay, and they will give us access to these views to see about system information. So among all these 34 views, not everything we use, but there are certain things we will be using. I will tell you. Okay, because we will be using them frequently once we starting working as a Snowflake developer or DBA, like that. So first and foremost thing is tables, information schema dot tables. Okay, so information schema dot tables. Okay, for example, it will have all the information about our tables. Okay, I will tell you. First, let us create one table, and then I can help you. So go to worksheets. Okay, so from worksheets, of course, you can have a SQL worksheet and create a table and insert data. Okay, that is one thing. Okay, so for example, create table, table name. Okay, insert all this thing. Okay, but I want to create table on my own. What is today's concept? Today's concept will be system tables. Okay, Snowflake system tables. That is our concept today. Okay, Snowflake system tables. Okay, so that means we want to see what are all the different system tables used within the Snowflake for our regular analysis. Okay, system tables. So that is the discussion today. So for that, I'm creating one table because you see our Snowflake expired, right? So I have created this account again. So I lost all my tables. Otherwise, I used to have tables within this public schema. So I will create one more table just to show about the Snowflake system tables. So okay, let's let's click on that public. Let me create a table. Okay, create table, dpt number, integer, dname. Okay, so create table, dpt. Okay, department number, integer, dname. Okay, varchar, location, varchar. Okay, then create table. So this table created. Then I will be able to see this within my public. You see public. Okay, department table is created. Okay, so now, okay, table details we can see table details. Okay, creator, replace table, department number, rename, location, and all. Okay, if you want to see columns, you can see columns. Okay, if you have data, you can see the data also, but we don't have any data. We just created. Okay, so now, okay, now we have department, right? So see, as soon as you create table, we could able to see that under tables. Okay, in the left hand side. Okay, under tables. So click your cursor on table. Immediately you see right hand side load data is enabled. Okay, load data is enabled. So let us load some data into this table. Okay, let's load some data into this table. Okay, load data. Click on load data. Okay, so then this window will come. Drag and drop to upload files or browse or add from stage. Okay, if you have files already, okay, so you can click on add from stage. You see these files can be, you see, csv or json, orc, whatever it may be, if you have already in file format. Okay, or you can also browse. Okay, either any of these options will work. So of course, add from stage, you can click here. Okay, for example, if you have that stage already created, you can give that stage name. Okay, so let's say, wait, where is that? Yeah, department. Click on department, click on load data. Okay, so then this window will come. Okay, I have already some data. I want to load it now. Okay, this department. Okay, so yeah, click that. Then see here options. We have to see the options. Okay, my public, and then create table DPT. If you want to create new, okay, create new table, then you can click. Otherwise, just select the table. Data will be appended to the existing. Then next, click on next. Here you see select the format. Okay, mine is a CSV. Okay, so mine is a header. So if you don't, if you have a header, I have header in my file. So you should select header only. Okay, if you select header means it must first skip the first line. Otherwise, see, I will show my header also, my file. See, this is my file. Okay, so generally in the real time, we will get files with header. If header is not there, for example, this is not there. How do you know what is this triple one, what is the sales, what is this Hyderabad? How do you know? You don't know. Okay, especially we'll have a lot of columns and lot of data will be there. So best practice we use in real time is we'll send files with header. Okay, so when we send files with header, we must skip the first line while loading because first line is a header. Okay, so that's why while defining properties, we will specify it's a header means skip the first line. Skip first line. Okay, so already it is CSV, so comma. Okay, comma is the default. Okay, fine. So remaining you can leave it. Okay, so yeah, if you want to show SQL, you can see SQL. Okay, this is the way it is the load script. Okay, so copy into department from that file. Okay, files. Okay, your file name department.txt. So all these things it will automatically create. Okay, so then you can click on load. Okay, so successfully loaded data. Okay, into department table, 3 rows were successfully inserted. Okay, so you can click on done or you can click on query data. You can click on query data. Then it will take you to worksheet or it will select star from so and so. Okay, so you can remove this limit. Limit generally will apply to limit the number of rows. Okay, so you can give select star from table. Okay, so this is the data. Okay, we have inserted. Okay, so this is the table. Okay, so I have created this table. Similarly, I will create a view on top of it. Okay, how to create view? Of course, we can create from console or we can create from here also. Okay, we'll create from console only again. Okay, so go to public. Okay, so come here, create view. Okay, so standard view. Same, it will give the syntax. So just give create view name. What is your view name? Repeat underscore view as select statement. What is select statement? Select star from DEPT. Okay, so then you can click on create view. Okay, we got created. Create a replace view. Okay, database name, schema name, view name, columns, and select star from whatever query. Here I gave single query. Okay, simple query. But in real time, you may have one page query or two page query. Okay, so it doesn't matter. You just need to place your query here. That's it. So then you can also see columns, or you can also see, if it has data, you will see the data here, data preview. Similar table also. Okay, you can see table details, columns. If you have data, you can see in data preview. See here, we're able to see the data because this table has data. Okay, so now what we want to show you is I want to show about system tables. Okay, now we have one table. Okay, one view. Okay, so these details. So how to see or how to know the information about the system tables. Okay, I said that information schema is the schema, okay, from where we can query about system data. Okay, so in information schema we'll have different views, okay, which will hold the information about the system. Here two terms you need to know. Information about the system, which I already said, it's a metadata or data about data, or sometimes people will call data dictionary. Means it will have information about the Snowflake objects. So all that information will be there in the information schema. So in the information schema, you will have some views. These are created by whom? Information schema did we create? No. When the time we log in only, it's there. Okay, even for example, MyDB is I created. As soon as I create MyDB, these two came, information schema and public. Okay, so for example, the Snowflake is their own. It came with the system, but it also has this information schema. Like that, anytime you create any schema, okay, information schema will be there. So it comes by default automatically. Okay, because it will have information about everything that you create within that system. Okay, now let's see what is there in this information schema. So these are all the different views that are available within the information schema. Okay, within that we will be using some of them frequently. What is that? For example, information schema dot tables. Same thing. This, if you work with any other database, you will have an idea. In Redshift also we have, tables. Okay, system tables. There is also we have, tables, views. Okay, all columns, all those things. So okay, now let's see what is this tables. You need to query information schema dot tables. Okay, so then we will be able to see what is the information it will have. Okay, let's query that. It will have all the information about all the objects that are available within the Snowflake system. Okay, see what are all the tables. For example, if you have worked on Teradata, it is like dbc.tables. There is also tables. In Oracle also it is there. Okay, so tables. So it will have all the information about all the objects. For example, you see in the public schema, we have department and department view. Within the information schema, whatever is there, they are also given within the information schema. Okay, see here schema name. So whatever is there in the information schema also, you will be able to see. Okay, so information schema dot tables, information schema dot columns, information schema dot views, information schema dot databases, information schema dot table privileges, information schema dot user privileges. Okay, information schema dot functions, information schema dot procedures. Okay, so information schema dot object privileges, information schema dot stages. Okay, information schema dot table constraints, information schema dot classes, information schema dot load history, information schema dot pipes. Okay, so yeah, I those are the important things which I read. Okay, so remaining actually not that much frequently used. Okay, right now we are seeing information schema dot table. See, this information schema dot table have information about information schema also. Okay, that's why we are able to see information schema dot tables, information schema dot columns, information schema dot views, information schema dot table privileges, information schema dot user privileges. Okay, information schema dot databases, information schema dot functions, information schema dot procedures, information schema dot stages, information schema dot table constraints, and information schema dot load history, information schema dot pipes, information schema dot table storage metrics, all these things. So if you can know about them, that's enough actually. Okay, so information schema dot tables we know. For example, information schema dot information schema we don't need because it is the metadata schema. So we can apply where table schema, where table schema equals to public, means here I'm applying public, but in real time you can apply whatever the schema name. So if you apply, then whatever is tables are there within that public schema, you will know it. Okay, so here one thing you need to observe, see, when I give small letters, small public, it didn't give any information. Okay, so we may get confused. Hey, I have created department table, but it's not coming. So what happened? Okay, so it's case sensitive. So it's storing all the information as the uppercase. So you can give cap letter, table schema equals public. Then you can see all the whatever tables, okay, or views that you have created here. So okay, database is mydb, schema is public, table name is department. Okay, so here you may ask, sir, one is view, one is table, so why both came? So you need to identify based on table type, means actually it is object type. So it's a table, it's a view. So based on that you can see whether it's a table or view, whatever it is. Okay, so table name is department. If it is a view, means view name is department underscore view. So okay, table type, okay, table and view. Is transient? No. Okay. Is there any clustering key? No. Row counts. If you have any rows, it will come here. Bytes. Okay. Retention time. Self-referencing column. Referencing generation. User-defined type catalog. User-defined type schema. User-defined type. Is insertable into? Yes, of course. Is type? Yes. commit action. See, created, when it's created, when it's created, when it's altered. Okay, so that's what I'm telling. What I said about dictionary, why we need data dictionary, we want to know the information about the database objects. Okay, when it's created, who is created, okay, when it's lost, altered, all this information we need actually in the real time when we are working. For example, we are doing data cleanup, okay, in our work. Data cleanup means a database is occupying unnecessary storage. We want to remove the database objects which are not accessed last 90 days. Okay, last 90 days which is not altered or which is not accessed. Then how do you know when this object is created? For example, a table is created some 3 years ago, okay, but last altered or last accessed is nowhere decently, then we can take action on that. That's why in that kind of situations, this system tables will help us actually. Okay, see, when it's created, when it's last altered, it will have date and timestamp, and last ddl. Okay, when the ddl was last again altered or modified. Okay, okay, last ddl by who created it. Okay, the user. So who has created also will come here. If you are, for example, my user is Krishna Redship, it will show my user. For example, the user who created this table has left the company, and this table is, let's say, created by him and it's not used by anyone, then we can drop this table. So that will add up the space. So for such kind of database maintenance activities, okay, database maintenance activities, and for automation kind of thing, okay, for cleanup activities, these system tables will help. Okay, so that's why in introduce sometimes, okay, sometimes they will ask. Okay, so for example, I want to know when my table is created. How do you know? Okay, information schema dot tables, where table name equals so and so and schema name equals so and so. Or you can just give schema name equals to so and so, it will show all the objects information of that schema. Okay, so is temporary. If it is a temporary table, it will come yes. Auto clustering on. If it is on, it's come yes. If no, no. So, and also one more thing that we can, you observed or not, it also shows number of rows. See, row count and number of bytes. That means it is like in every, as I already said, in every database we'll have this kind of system tables. In Redshift also we have. Okay, so in every database. So here you see bytes. Bytes means how, what is the size of this table. Okay, so as I already said, when we are cleaning up the data, okay, so let's say you observed one large table, then you can see whether this large table based on bytes. Okay, so based on bytes, okay, you can see its size. Okay, so based on bytes, you can see when it's last created, okay, when it's last altered, okay, and yeah, when it's last modified ddl, last ddl. If it's not accessed by last so many months or something, and this table is not used actually, okay, you can drop it to claim some space. Okay, so basically this table or this, okay, information schema dot tables, where schema name, where table schema equals to your schema name, will give all the details about the objects. For example, if it is a table type, it's a table. In case of department, in case of department view, it's a view. Okay, so we already discussed all these things. Transcend table. Okay, transcend means we discussed, right? Temporary, transient, and permanent tables. Okay, temporary table means temporary, permanent tables means permanent. Transient table means it's like permanent table, but retention is only 1 day. You see, retention time only 1 day, you cannot change it. Okay, so this also will store the data till you delete it. So that's what is transient table. No, that means it's a permanent table. Clustering key, if you create table with clustering key, it will come here. Otherwise you don't see anything because we not created this table with clustering key. Row counts, okay, if you have many tables in this schema, you will see all the tables row count and their sizes. This also will help us because, for example, your manager ask, hey, can you please identify what are all the top 5 tables, okay, which are highly occupying the storage. So same thing, at that time you have to query this schema only, information schema dot tables, where table schema equals to so and so yo. Okay, your project schema you can give. Okay, order by bytes descending you can keep, order by bytes descending limit 5 you can keep here. Order by bytes, we got. Okay, so in case of nulls preceding, okay, so we can mention nulls last option also, otherwise we can do this order by bytes ascending. Okay, then it will throw nulls to last. See, it got about the department. So because right now in this we have only two, so I just want to show this table in the output. So otherwise you can also put one more filter, table type equals to base table. Okay, means you want to see only for tables. Okay, table where table underscore type, where table underscore type equals to base table. So that means all base table, okay, where table type equals to base table, order by bytes descending. If you want 5, you can put limit 5, but here we don't have 5 tables. Okay, we have only one table. Okay, so I'm just keeping one so that it will show only that one. But if you want to identify 5 tables, you can just give limit 5. Okay, so I think I gave where 2 times. See here, where and where. Okay, where you should use only once. I mean, whenever you apply filter, you should keep where, and all filters you can put and. Okay, so yeah. So select software information schema dot tables, where table schema equals public and table type equals to base table, order by bytes descending. Okay, limit 1 means only top highest space occupied table you will see. Top 5 means top 5 tables you will see. Okay, in this case. So then you will see, okay, what are all the objects, okay, with the highest space. Then you will observe, okay, when it's created by whom. Okay, so when it's lost altered. Okay, so whether are we using the table or not. Okay, so all this thing. Okay, so for example, See, for example, I created backup table from the EPT. Okay. So now if you run this table, okay, I mean it also will show within the dictionary. Okay. So since I put limit 1, so it showed limit. Okay. If you remove that limit, or if you put limit 5, or just remove the limit, no problem. See, it showed both the objects. Okay, department and department underscore backup. Okay, so both are base tables. Is transient? No, means both are permanent tables, and row limit sizes and all. Okay, so obviously the backup table we don't use it, right? Backup table is created for taking backup, and just in case if anything goes wrong, we want to restore. So when we are doing this kind of analysis, as soon as you see this backup, you will see, okay, this table is created, okay, so and so date. I don't think we need this. So we'll be able. So let's say you saw this when you are doing analysis, okay, and by that time it was already created a year ago or 6 months ago. Then obviously you think, what is the use of this backup? It's 6 months, 6 months old table. So then you can clean up this table automatically. So like that, this analysis or this table will help us to identify what are all the tables. Okay. So since it will have all the information about this table, so you can make decision. Okay, which are the tables to be cleaned up, means removed from the system. Got it right? So yeah, so information schema dot tables, very important, because it has all the information for us. For example, you want to know, even this is another context. You want to know what is the clustering key. For example, you are working on some performance optimization, and okay, some tables involved a query is running longer. Then same query you will run to see what is its clustering key. Okay, is there any clustering key? So here there is no clustering key. At that time you will try to create clustering key. Okay, that is another use case I'm just telling. Okay, so I'm telling this table information will help us a lot. So, and row count, so you can see the data that is there in this table, and bytes means size, you can see retention time. Okay, you can see the retention time. Okay, so if you want, you can change the retention time. So but anyway, this is not permanent table, so you cannot change it. So at that time you have to create it as a permanent table, and then make the retention. Okay, retention. Okay. Okay, reference is insertable, yes. Is type, yes. Okay, created, last altered. Okay, so last altered by is temporary, no. Okay, so similarly, you can see the views also. For example, if you want to see what are all the views in my system, okay. So then table type equals to not base table view, or if you don't know anything, just write like this: select star from dbc, information schema underscore information underscore schema dot tables, where schema name equals to your schema name. Then it will show all the objects. Okay, tables, views, everything. Then okay, you can filter based on, you see, table type equals to view. Okay, table type equals to view, so you can apply here view caps. So if you give view, it will show only the views, because in real time also we'll have so many views. Okay, and it not only from your project, you will get from different projects. That way you have to apply filters based on schema, because your project schema is different from others project schema. So we need to apply filters in such a way that we get the required data. So that is the main funda. Okay, so you need to filter or you need to write a query in such a way that it will fetch only your data. So if your schema is public, you will keep public. If your schema is something else, for example, your schema is something like you are working on some revenue, okay, revenue. Then if your schema is revenue, then you can put schema equals to revenue. Something or BI rev. Then you can apply table schema equals to BI rev. Something, whatever name you will put there. And table type view, then it will give only views. You may have 100 views here, okay, in your project. They all will come. So then you can see what is that, view name, okay, who is the owner, okay. So view is transient, no, okay, clustering, no, row count, no. Anyway, it's a view, so you don't find any row count because what is view? It will only access the data from the base table. So you don't see any row counts or anything bytes. Why you don't see bytes? View, does it occupy the storage? No, it don't occupy the storage. So you don't see any bytes information or anything. So is insert tool is type yes. Okay, so when it's created, when it's last altered. Okay, last altered by whom? Okay, user. Okay, so now what I will do is insert DPT view, select star from DPT. I want to run this query. Unexpected department view data. Okay. Insert my DB dot UBLIC dot view. Actually, I want to tell you something. So insert this one. Okay. Department underscore view. Okay. So insert into this one. So let's see. Okay. Yeah. This is what I want to show you. So see here, what is that I'm trying to insert? Trying to insert into a view. Okay. So my question is, can we insert into a view? That is my question. Sometimes interviewers will ask, can we insert into a view? Actually, answer is no. Okay. So that's why I'm trying to create into a view. Okay. Insert into view. What DPT underscore view is a view, right? So I'm just trying to insert and see whether it will insert or it will throw an error. Okay, so I want to show this error to you. Insert into view, dbt underscore view is a view, right? Select star from table. So insert statements target must be a table. So that's what he is telling. Okay, again, whatever you are inserting, it must be a table. That means you cannot insert into a view. Okay, so I just want to make clear in that. Okay, so we cannot insert data into a view. View is just, what is view we define? View is it's just a logical access to a base table. Okay, whenever we create view, it will access the data from its base table. Okay, so it will not have any storage also. Okay, for example, in question they will ask, okay, I have a view, okay, that's created on top of department table, but I want to insert into a view. Can we do it? Your answer should be, okay, we cannot directly insert into a view because insert statement's target must be table. If you want to insert into a view, you must insert into its base table. What is its base table? So its base table is department. So now you see I changed this to base table. Insert into a department, select star from department. Then it will insert into base original. You see. Now the department table will have how many rows? Earlier 3, now 3. So now you can select star from department underscore view. You will have those 6 records because we inserted 3 records into its base table. So if you want to insert data into a view, you must insert into its base table. Okay, you cannot directly insert into a view because in view you cannot insert data. Okay, whatever you want to do, you need to do its base table. So I inserted into its base table. So when you query the view, you can see the view. I mean view data. So the newly added data. So now you can see everything from here as well. Okay, and also from here as well. Tables views together in single view. See department view, department underscore backup. This is view, others are base tables. See here, this is base table. Department has 6 rows. Okay, so backup table has only 3 rows because backup table is old. Okay, so same thing, remaining all, you know, same created, lost, altered, lost detail, all these things. Similarly, okay, so you can see information schema dot tables, information schema dot views. For example, if you see information schema dot views, you can see information about all the views directly here. See here, department underscore view. Okay, or if you give table schema equals public, then you will get only views from the public schema. Okay, because we don't want anything from information schema, right? So you can give table schema equals to public. Then you will get all the views. Table schema equals to public. Okay. Right. Table underscore schema schema equals to public. Okay. where I'm missing, where table schema equals to public. Okay, so in public, whatever views are there, you will see here. If you query information schema dot views, you will get only views from there. Okay, so since we have only one view, we'll get that from here. Okay, so information schema dot tables, information schema dot views. Okay, so information schema dot stages, information schema dot functions. Okay, in information schema dot tables, you will get everything, but in information schema dot views, you will get only views information. Okay, similarly, in information schema dot columns, you will get columns information. Okay, this is also, I mean, sometimes useful. For example, columns where column name. Okay, let me, where table schema equals to public. So column name, yeah. In real time, sometimes, okay, sometimes we want to find certain column used in what are all the tables. For example, department number is used in one table, DEPT underscore NO. In some other tables, D number, DNO. Okay, so we want to identify where, what are all the, tables it is used. In such cases, it is used. Okay, so where column name, where column name equals to DEPT number. Okay, so DEPT NO. That means we want to identify a particular field is used in what are all the tables. Okay, so sometimes in the while we are working, your manager will ask you like this: hey, I want to see, okay, in what are all the tables this particular field is used, because we want to change this field to, means actually this is related to data modeling. uh, because in some tables it's used DEPT underscore NO, in some tables it's used DEPT NO, in in some tables it's used DNO. Okay, they want to name it as, same name across all tables. So they want to identify where this DEPT underscore NO is used. Then we have to query this, you know, DEPT information schema dot columns, where, column name equals to so and so. Then it will fetch all the objects. It may be tables, views, whatever it is, with that column name. Then it is easy for us to change in those tables the field name. So yeah, this is one of the, use case they will ask. Sometimes we need to identify a particular field in what are all the tables it's used. Okay, similarly, sometimes we need to identify a particular table in what are all the schemas it is used. At that time also we need to apply filter on the table name. For that, at that time we have to use information schema dot tables. Okay, if you want to search particular table name. Okay, here you want to search particular column name, so information schema dot columns, like that. So similarly, So information schema dot tables, information schema dot columns. Okay. So information schema dot views we have seen. Okay. Similarly, use table privileges and usage privileges we can see from here. Means sometimes a particular user table name equals to table privileges and user privileges. This table privileges is the table which will help us, okay, who are all the users has access and what type of access they have. Okay, yeah, sometimes if you go in detail in the interview, they will ask, I want to see, a particular user, what type of privileges he has. Then we need to query table underscore privileges. Okay, it will show all the access that he has. Okay, so the tables on tables defined in this database that are accessible to the current user's role means who is the current user? Krishna Redship. So he is a account admin. Okay, so this has account admin access. Similarly, usage privileges. Okay, usage privileges also will have access on the what are all the access he has. The usage privileges on sequences defined in the database means sequences we said, right? Sequence means it will generate sequence number. So on such tables, if anyone has access, that will be listed in this usage privilege. Usage privilege. Generally, table privilege is the table we use if you want to see any user has any access on any objects. Okay, table privileges. It will have entry into this. If you have any user created and if you grant any access, all those access will be available in this table privilege table. Table underscore privileges. Sometimes they will ask, what are the different system tables, at that time you must be telling, I know information schema dot tables, information schema dot views, information schema dot columns, information schema dot table privileges, information schema dot usage privileges, like that. Then he will think that okay, okay, you worked something. Okay, so similarly information schema dot functions, information schema dot procedures, same thing you can just put here to know what are all the fields it has, functions. Okay, when it's created and what is its purpose, and similarly procedures. If you have any procedures, they all will be available here. Okay, but we don't have any procedures, so yeah, so nothing is coming out, only this is coming, nothing else. So okay, views, table privileges, usage privileges, functions, procedures, stages. Yeah, so this is another important. Okay, so information schema dot stages and load history and pipes. Okay, main is stages, information schema dot stages, stages. So it will list all the stages that are available within your system. Okay, it may be okay internal stage or external stage, whatever stage, it will show all the stages, okay, that are available. Okay, you see stage catalog means database, stage schema, stage name, okay, stage region, stage owner, created, altered. Okay, so all these details will be shown here. For example, okay, let's create one stage. You can create some yoga test stage. Okay, so test stage, same thing. It's like create stage, stage name. Then it will be there within the stage. Okay, in the left hand side. See here in public tables, tables will be there. Views, views will be there. Stages, stages will be there. Okay. So now you have one test stage, right? So within that, as soon as you click cursor on your test stage, you can see add files. This option will be there. You can add files to this. Okay, so you can also actually drag and drop or browse. Okay, so whatever you want to do, you can do. So we can also add the file. Means we are staging the file. Okay. So this is the file I have staged. So yeah, internal. Okay, storage is internal, and I have one stage now. Okay, so test stage. So now you can see this there. Okay, in information schema dot stages. Because we created one stage, right? So we can go and query within the worksheet. See, we can see our stages here. Whatever is it, like we can see all the tables in the information schema dot tables, all the views in the information schema dot views. Similarly, if you have any stages created, we can see that under information schema dot stages. Okay, stage or database catalog means mydb. Okay, schema public stage name test stage. Okay, so here we can see. Okay, stage type, it's internal named stage because this is locally we created. Okay, so account owner, account admin, stage owner, so when it's created, okay, when it's altered. So all this information we can see here, all the stages in the information schema dot stages. We can see all the stages here, we can see all the stages. Okay, it may be internal or external, everything we can see here. Similarly, pipes. Okay, so if you have created any pipes, we can see internal schema dot information schema dot pipes. Okay, so yeah, those are the important things. And another thing is load history. We can information schema dot load history will show, for example, let's see, it will have all the history about, you know, what are all the different loads we have done. Okay, so schema public, we loaded right department table, so that is there here. Okay, department table we loaded into department table. See what is the target table, what is the file we loaded. Okay, when we loaded, okay, status loaded, okay, or failed. Okay, how many records loaded, rows parsed. Okay, how many records, you know, parsed means syntactically evaluated and passed means successfully loaded. Sometimes some records will fail. For example, out of 3, 2 are parsed successfully and 1 failed, then it will show 2. Okay, how many are parsed. Okay, first error message, if you get any error message. Okay, if you any line number, if it fails, it will show line number. Okay, so first error. Okay, first error column name. Yeah, it will show the, you know, error column name. Okay, error count if you have any number of errors received. Okay, so actually this table will be used, okay, load history while debugging any load failures. Okay, while loading data, if you are failing any, you know, any records or any load fail, then we can query this load history and see, okay, is it successful or failed. If it's successful, how many are successful. If it is failed, okay, how many are failed actually, and what is that error message we received, what is the line number. Okay, so for example, you may have 1 lakh records or 10 million records. Okay, it will show the line number. Okay, where that particular error record. Okay, so first error line number. Okay, first error character position means which field it is, so that you can go and see character position. Okay, line column, it will give column name also. So then what else you want, you can directly go to that column name and see what is wrong with that field. So error count and error limit. So yeah, these are the, you know, dictionary tables we must say that I'm aware of, and you know, I will be using as and when required for my analysis. So that is what we need to tell in case of system tables, but sometimes they will ask about, you know, the system tables. Okay, that's why I just want to tell about this, you know, class. So what are all the information schema dot tables, information schema dot views, information schema dot columns, information schema dot functions, procedures, information schema dot stages, information schema dot pipes, and information schema dot load history. Okay, these are all the things that are required, you know, to know, or you must say that I know, okay, the system tables to do my analysis. Any questions? Okay, okay, cool. We can meet tomorrow. See you.
Sure, sure. Yeah. Thank
Okay,
you.
take care. Bye.